2 says that suppose this equation here has an integrating factor mu of y. So we're already told that it has an integrating factor. So that means that right now it's not exact, okay? And also that our integrating factor is a single variable function only dependent on y, okay? So we're going to find this integrating factor and then solve the ODE. Okay, so what we have is that, well, this equation here, okay, so the partial with respect to y of mu times p should be equal to the partial with respect to x of mu times q, once we know our mu here, okay? And if our mu is a single variable function dependent only on y, then we have that the left side is being expanded more. Well, we'll have more terms there, right? So we have partial mu partial y times p plus partial p partial y times mu is equal to mu times partial q partial x, okay? And then when we solve for, when we kind of formulate our separable equation here, we're going to have this is equal to 1 over p times partial q partial x minus partial p partial y times mu. So when we fill these in, we just get the following. So we have partial mu partial y is equal to 1 over p, and p is this thing. Okay, so that'd be y squared plus 2xy. Okay, and then times the partial of q with respect to x. So in the partial, or sorry, q is negative x squared. So the partial of that with respect to x would be just a negative 2x. Okay, and then we're going to subtract away when we take the partial derivative of p with respect to y. So that would give us 2y plus 2x here. And then we have our mu. Okay, so this thing can simplify. I'll just simplify on this slide while we have it here. So this is going to give us partial mu partial y is equal to 1 over, and I'll just factor out a y. Well, I'll just keep it there. Y squared plus 2xy on the bottom. And then this is times, well, a negative 2y, and minus a 4x, okay? And then times mu. So let's take this line here, and we'll continue this on the next slide. Okay, so now we have partial mu, partial y is equal to 1 over, and y squared plus 2xy times negative 2y, that is, negative 2y minus a 4x times mu. So this thing down here can actually factor out, and we can factor some other things out. So we have 1 over y times y plus 2x, that is. And then on the top here, we actually have, we can factor out a negative 2. So negative 2 is there, and then we have y plus a 2x, which is nice because we can cancel those out. So we just get partial mu partial y is equal to negative 2 over y times mu, okay? So when we solve this separable equation, we get 1 over mu times d mu is equal to negative 2 over y times dy. When we integrate on both sides, we get ln of absolute value of mu is equal to negative 2 times ln of y. Okay, and then mu turns out to be a 1 over y squared. Okay, so this is our single variable function, which is mu of y. This is equal to 1 over y squared. And now with that, we just multiply our entire original equation by that to solve, okay? So now we have 1 over y squared times our entire original equation, which is y squared plus 2xy times dx. And then we had our minus x squared dy is equal to 0. Okay, so once we do that, we get 1 plus 2x over y dx. That's our new p, right? And then minus x squared over y squared dy is equal to 0. Okay, so now this equation here is exact, alrighty? So once we have this, we can just solve like normal, and we'll continue this on the next slide where we have more room, okay? So now we're at 1 plus 2x over y times dx minus x squared over y squared dy is equal to 0, okay? So now our potential functions here can be obtained by the following. So this is our new p hat, right? And this is our new q hat. Don't forget this minus sign that goes with it, okay? So our p hat is equal to del f del x, which is equal to 1 plus 2x over y. And if we integrate with respect to x here on both sides, we get our first potential function is the following. So f of xy is equal to x, and then this is going to be plus x squared over y. Then we have to have our plus phi of y, just in case we have a single variable function of y there that disappeared. Okay, and then when we're going from the other way, we have q hat is equal to del f del y, and that's equal to negative x squared over y squared. Sorry, that 2 went a little funny there. And when we integrate with respect to y, we're going to get the following. And now we have another potential function. F of xy is equal to, and this turns out to be an x squared over y simply. Okay, and then we have our plus a single variable function of x. Okay, so this thing here actually turns out to, we don't need that, it's 0. And this thing is going to be our x. Okay, so finally, we just get that our solution is going to look like this. F of xy is equal to x plus x squared over y, and then is equal to c. Alrighty?